Hi, good morning. This is Divya from SNS College of Technology, belong to the Department of Electronics and Communication Engineering. Today we are going to see about IoT system architecture and the course code is 19 ACT 213. Today we are going to discuss about the vehicle to vehicle communication topic. In that, what is vehicle to vehicle communication? It refers to the exchange of information between vehicles in close proximity to each other using wireless communication technologies. The exchange of data enables vehicle to share information such as speed, position, acceleration, direction, and other relevant data points in real time. Vehicle to vehicle communication systems facilitate the development of cooperative safety applications and enable vehicles to collaborate with each other to improve safety, enhance traffic efficiency, and enable new functionalities for connected and autonomous vehicles. This picture shows how the vehicles are communicated with each other so that we can calculate the distance. It will give the information about the speed of the vehicle, direction of the vehicle, and the position, how long the vehicle is to be. These are the information that we can collect from this, from collect through the vehicle to vehicle communication protocol. Next one is importance of vehicle to vehicle communication. In that, why we are using vehicle to vehicle communication means we should avoid a collision during the traveling in safety. Collision avoidance enables a vehicle to exchange information about the speed, direction, and position. This information allows vehicle to detect the potential collision risk and take preventive actions such as warning the driver or automatically applying brakes to avoid accidents and collisions. Real-time hazard alerts. It can transmit alerts about hazardous road conditions such as icy roads, accidents, or sudden traffic slowdowns. This timely information helps drivers anticipate and react to dangers more efficiently and reducing the accidents. Enhanced emergency response. In the event of any crash or any emergency, vehicle to vehicle communication allow vehicle to communicate quickly through the status and location to the nearby vehicles and emergency services. This rapid exchange of information can expand it in an emergency response efforts and potentially save lives. Traffic flow optimization. By sharing real time traffic data, including congestion levels and traffic pattern, it helped to optimize traffic flow and reduce traffic jams. This led to smoother traffic movement, shorter travel times, and fewer opportunity for accidents caused by congestion related factors. Adaptive cruise control and lane keeping assistance. Vehicle to vehicle communications support advanced driver assistance systems ADAS such as adaptive cruise control and lane keeping assistance. These systems utilize information from nearby vehicles to maintain safe following distance and assist with lane changes and enhancing overall driving safety. These are mostly used in an autonomous vehicle. Redundancy in sensor systems. It serves as a redundancy mechanism for onboard sensors such as cameras, radars, and lidars. By cross-verifying information with the neighboring vehicle, it helps to compensate for limitation or failures of individual sensor systems and improving overall reliability and safety. Next one is components of vehicle to vehicle communication. These are the components that we are using for vehicle to vehicle communication. First one is an onboard sensor. It utilizes various sensors to collect data about the vehicle surroundings. It can sense radar by using radar, lidar, cameras, and ultrasonic sensors, which capture information about nearby vehicles, pedestrians, and road infrastructures and other relevant objects. Next one is a communication hardware. It requires a dedicated communication hardware installed in each vehicle. It can it can be a transceiver capable of sending and receiving wireless signals and antennas for transmitting and receiving data and onboard processors for processing the incoming and outgoing messages. Next one is a communication protocol. It follows some specific communication protocols to govern how data is exchanged between the vehicles. Communication protocol include dedicated short range communication, DSRC, and cellular vehicle to everything. CV2X. These protocol define the standards for message formatting, transmit in frequency, encryption, and other communication parameters. Next one is the data processing algorithm. On receiving data from outboard sensors, we have to process the data by using a machine learning algorithm. It will extract the relevant data points such as speed of the vehicle, position and direction of the vehicles, so that we can avoid collision and risk and other safety hazards. Next one is a message generation and transmission. It have to transmit messages containing relevant messages has to be transmitted to the nearby vehicle. These messages typically include information about the vehicle speed, position, acceleration, and other contextual data. Message may be broadcasted periodically or triggered by some specific events, or while applying sudden brakes, or while we changing a lanes. User interface. It often includes user interface that provide feedback to drivers about nearby vehicles, traffic conditions, and safety hazards. It may consist of visual displays or auditory alerts or haptic feedback to keep drivers informed and alert them to relevant information in real time. How vehicle to vehicle work communication works. First one is data collection. It will collect the data from the sensors. Next one is the data processing, analyzing the collected data from the sensors to detect objects and position and speed of the vehicle. Then message generation. It will automatically detect the speed, position using dedicated short range communication, so that it can generate a message. That generated message has to be transmitted using a dedicated transceivers. After that, a message reception, extracting incoming data from relevant informations, extracting incoming data of relevant information from the vehicle. So next one is a data fusion and analysis, to combine the data from multiple sources so that we can avoid a collision. Driver alerts and decision support system will alert the driver uh, of potential risk and hazardous roads conditions, so that if there is any lane keeping, or they have to change the lane. These are the systems that can be utilized by using a driver alert system. Next one is a continuous communication. It should be periodically updated so that the system can update and reflect the current status. Next one is benefits of vehicle to vehicle communication. It will improve road safety, enhanced collision avoidance, real time hazards and traffic flow optimization, cooperative driving behaviors, enhanced intersection safety and support for autonomous vehicles. Thank you.